All right, so we continue with our daily coding challenges. This stream is for entertainment purposes only, like my entire life. And today we're going to see if we can solve another problem under 40 minutes. Maybe yes, maybe no. Well, so let me check that everything is working fine. Seems like that. Right, so let's go ahead and select random problem. Chances are it's a hard problem that you're not going to solve, but who knows? Maybe today will be a gift and it will be an easy one. So pick one, and it's hard, right? Medium, okay. Uh, Graph theory. But, oh, seems like an interesting problem. So let's see what's that one. There is an infrastructure of n cities with some number of roads connecting these cities, obviously. Roads I is city I to city B. Why you need, oh my God, why you need two indices? Why you need indices I for cities A and B? So silly. There is a bidirectional roads between city A and city B. Network rank of two different cities is defined as the total number of directly connected roads to either city. So there is some definition called network rank, which is total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. Okay. I see. So if there are two nodes, the sum of the outgoing edges or whatever, the overall edges that are ingress or egress to the city of two nodes minus one, if they are connected. If they are not connected, then we don't need to subtract one. Then there is a second definition called the maximal network rank. That's the name of the problem also. Of the infrastructure is the maximum network rank of all pairs of different cities. Given the integer n and the array roads, return the maximum network rank of the entire infrastructure. All right, so we give in example one here, right? So roads, n is number of cities, the network rank of cities 0, and 1 is 4. 1, 2, 3, 4. And there are 4 roads that are connected to either 0 or 1. The road between 0 and 1 is only counted once. Network rank of all pairs of different cities. So we need to find a pair of cities for which this rank is the maximum. And obviously, this can be done easily like in quadratic time, but I would imagine there is some trick that can be done. Like we can sort nodes based on the amount of edges they have and start the node with the maximum one and then find the second maximum one, and maybe that will guarantee us the maximum. Who knows, right? Example 2. So they select 1 and 2 as the solution because in this case is 1, 2, 3, 4, 5, right? Example 3, n equal 8, cities, roads, output still 5, rank of 2 and 5 is 5. 5 of 2 and 5 is 5. Notice that all the cities do not have to be connected. All right. So 5, 6, 5, 7. It's an interesting example. So they can be actually. It's not like a tree or anything. So it can be like a forest, right? So there are many graphs that not necessarily connect with each other. Nice. And our goal is to find two nodes that have the most adjacent edges, right? And how do we do it? Well, one way is just to have a map that tracks adjacent edges. It's linear time to file it, right? And it will be node ID to set of indices. Once we have this map, we can just find two larger sets. Technically, all you need to do is to have quadratic complexity. All right, we can have hundreds of cities, but we can have at least quadratic complexity with respect to the number of cities. I have no idea how we can select the maximum pair without it. So without even going to whiteboard, let's just implement this option quickly. See if it passes the time limit thing. If not, then we rethink the solution, because so far you see the limits are that number of cities is maximum is 100, right? So it like what's the point here, right? If it's 100 squared is 10,000 iterations. It's not like too much. And the rows length, yeah, can be huge, but we don't care. So here's the simple unordered map that maps int, which is not city, to unordered set of int, which is city to roads, right? And it's quite easy. Well, technically we can even allocate the hash function, which is n, right? All we do is this: for const auto road in roads, we just go ahead and say city to roads. So the vector of two values always, right? We need the index as well. So okay, let's do this then traditional way. So we say int I as an example equals 0, I less road size 9 plus plus. So then we're left with only what? So city to roads, we say roads I 0, insert I. Um, ah, so the problem is exactly if we need to subtract one or not, but okay. This will be linear time with respect to number of, damn, it will be very slow. I already see it. Just because of this stupid one edge is not counted thing. All right. Whatever, let's try. At least the algorithm will work, right? You can always go and optimize it further and think on more complicated data structures. So once we have this, we do this for int I equals 0. Should we say I again? Whatever. We can say A as an example, right? As we had this example. So A is less than what? Than N. A plus plus. Because the problem is symmetrical, we don't need to check in the reverse order, like check status between B and A versus A and B. So we can just say int B is equal to A plus 1. And actually it can be N minus 1, right? Because we don't need to check the last one. The B is less than N and B plus plus. Life is great. So then we say int max cities, int max rank equals 0. Then we have int rank here also, let's say equals 0. No, it's actually equals city to roads A size plus same thing B size. And then all right, I see. We might, so all we need to do is basically have a Boolean map, or like the adjacent map. So it's a little bit intensive one, but we can do this. We can check that bool connected, right? In the sense that directly connected of two numbers, right? N and N. And all we say that here connected. So CP 2D bool array default value. It should be false. Default value C++. I don't want to initialize it. The following code doesn't work because location matrix is not allocated. Bool location matrix equals false. Okay, let's do this. Should be straightforward. Thanks, Stack Overflow. All right, so it's false by default. So all we do here is saying this thing is equal to true, right? Or 1 or whatever. So all we need to say here is minus connected AB, I wonder if there may be multiple edges in between two nodes. Just wonder. Did they say that there is no indicate the bidirectional road between cities A and B. We will see. We will see. If so, then we need to turn this into integer, right? And just say O zeros. But if we have one, we add one here, so it just saves a little bit on the memory because we use Boolean. Connected, then -1, otherwise -0. Right? Should be super straightforward. So then we can say, and this. All right, and that's it. And then we say, once we have calculated it, that max rank is max between max rank and actually we can maybe move it directly here. Let's just ensure, yeah, it's better looking like this. Then we don't need even this one. All right, so this is the fastest algorithm so far I have in my head. Not sure if we can solve it faster. So we've guaranteed to have at least, each pair of cities has at most one road connecting them. So we can keep Boolean here. That's nice. A not equal B. So there's never a case when the road just connects the city like this. 2 to 100. Number of roads, we don't care. It's linear anyway. So it's, or let's call the number of roads as E. So it's linear here. And this part is, or let's call it V, basically squared by half, but again, for the time complexity, it doesn't matter. So the total one is, this one is, or V squared 2 plus E. All right, so this is time. Should work. I hope so. If they don't like this one, but it's only 100 cities, so we shouldn't be worried much. And the space, so we have the matrix of cities. So technically the map here, it will be two edges, right? Because it's bidirectional. So every edge appears exactly in two keys. So this overall one is basically or E plus, and again, this one is V squared, right? But to be honest, this is Boolean, so it's just one bit of information per every pair. So it's one bit here, and this is 4 bytes for every edge here. So, but still, we should. So we basically came up with the same algorithm everywhere, right? Same space, same time, same space complexities. Right. Theoretically, we should also, go and debug it, but let's just run it and see if it compiles, and if so, just submit and see if it works. And but then, and this is ridiculous. Okay, let's do vector of vectors. But then I need to add a vector, whatever. This will run, but not necessarily will work. So what it says. And why? Because the size is is not integer, technically. But we know that we can safely cast it to the integer. I hope so. Int this guy, right? So let's just then move it like this. Run the code. I guess it's connected. This one is for static cast, and we need the extra one now. You're killing me. Right. So let's just have, plain and simple, let's just have this thing. So we done. No. I don't care. It will be still technically n square here. So this is whole. So all we need to do is select this city to city. Right? And then here we say city to city, A count B, yes, then subtract 1, no, then subtract 0. Whatever. Run the code. It's so straightforward with one-dimensional arrays, and two-dimensional arrays is always like headache. You need to have separate functions to initialize them and whatever. I don't want to spend extra time to save a few bytes here. Yeah, just submit and see if it passes the time complexity check. Oh, it doesn't pass the input 2 cities, 1, 0. Output 2, expected 1. How on earth is this possible? I don't understand. Let's see. Then subtract 1, right? If it contains B, C out, let's say CTA equal A, and CTB equal B, are connected, and then city to city count B, right? All right. No. What do you mean no? We literally insert for zero index, for zero city, city 1. Ah, yes. It's bidirectional because we have no idea how indexes are, so we should say also 1 and 0. All right, now should work. Hey, we passed. Very slow. Very bad scores for both. I guess you can do something better than v square here. And maybe we shouldn't pass it. It's just the trick that we don't go through all combinations. It's technically v squared divided by half. Memory, because we use two maps, obviously. I would imagine you don't need this map, right? So you can use this Boolean matrix, 2D matrix, that will save you a little bit. What else? Oh, actually, you know, actually, it can be easier. You can have, so we have some time. Let's try to improve a little bit something. So I'm not sure if this is gonna make tons of difference, but at least here we can have set of what? Of, it's from 1 to 100, right? So we can use string, we can use maybe pair. And it's not and, by the way, is it? Yeah, it will be and because it's and to something. But pair will be number of road size. Pair of two integers. Here we go. Right? So all we need to do is make a pair, city to city, insert, make pair of this and this. And theoretically, we can also put them opposite way, but because we're trying to save on memory as much as possible now, we won't do this. So instead, we will see the count, make pair a, oh, can we do, whatever. Make pair or reverse, right? If either these or these, then we subtract one. Otherwise, we don't care. Right, something like this. Run the code just to make sure it still compiles. No, obviously. I guess you can use pair right here. Hasher, yeah, I mean, let's just use string. Who cares, right? And so it will be insert to string plus to string this guy, right? And something plus like this, whatever, right? So then theoretically, we now should do the same thing here, calling A, B, and vice versa. This is A, this is B, and vice versa. Yeah, I don't think we'll save a ton like this. But let's see. We can always undo things and just see what's the best course we can get here. Other than that, I don't even know how to save more memory. Unless we change the algorithm itself. So it passes. So we had what? 51 megabytes of memory. I would imagine it's still something like this. It doesn't capture. Oh. All right. So we shaved about 5 meg of memory. Time became worse though. Damn. I wonder if we can say whatever. Let's submit one more time. And another time. Yeah, okay. So I don't really like these structures here, so I would return the regional map we had. What if I first do this bool connected, right? And then say connected equals to false. How does this sound? It would work in this case. I don't know. Do I need? No, I don't. Okay. Should be here. And then let's try this. Connected. Yeah. It's one. True, and this should be symmetrical, I would imagine, so we won't just flip another flag here from 1 to 0. And then it will be very clean here. Connected. Yes and no. All right. So we spend 4 bytes here. Yeah, v square of 1 byte and edges. But edges is the only evil, this unordered map that we have. But do we really need it? Yeah, I think so. So yeah, let's just again run the code, see if it works. compiles. What do you mean? Can I make it const so you don't complain? I can initialize it with the variable. Interesting. Like need malloc or something like that. Oh, god damn it. All right. Let's see where we were before that. We were here and here, right? No, we don't need pair. First of all, it's n. Oh. So memory will be worse, but time will be faster. All right. I think this is our best shot so far. Should we stop here? 30 minutes. Okay, let's stop. So today we even haven't used the whiteboard because the algorithm was sort of straightforward. But let's also check what's the best solution here. They use vector of booleans to say connected. And then a vector of integers. All right. Oh, yeah. You don't need actually unordered sets. It's a little bit overkill. Exactly. And they use vector of booleans for connected to say if they're connected or not. So we use map for that. But yeah, but I mean, the algorithm itself is the same. By the way, you don't need to have n. You can have n minus 1. Here, there's just this max, this plus this minus connected. So it's exactly what we did. The data structure is better though. So they used vector to vector and vector of boolean of n. So it will initialize directly O to false, and it will be n like this. So interesting. So yeah, this interesting initialization. So interesting insertion, then it's straightforward true, and then you don't even need to see if they're connected or not. You just basically compile them. Just basically increment these integers, right? Because all we care is how many edges we have. We just basically took the size. We don't care of individuals things. Initially, I started to use them just to check if they're connected, but then you can have separate structure here. Yeah, I think it's a very easy, straightforward problem. And our submission is 12 points here, and let's say we round up, so it's 6 points, so 18 points total out of 200. Whatever. So let's switch to the whiteboard, and let's go to, this is 12, and this is 6. All right. Yeah, I don't know. I guess we haven't deserved to see fireworks today, but okay, whatever. We solved the problem. Hey, so Right now, it's just the structures we've used are not the best one. Let's, by the way, check what was this. Let's imagine this is just vector. All right, event of in size of n. So all we do here is just to say cd to roads. This one plus plus. And this one plus plus. And then we just say what. I don't even need to static cast this. You just say this plus. Oh gosh, it's so much better now. If I just used at least vector of integers here. And then instead of this, we're using again vector of bool. Let's do this. Vector of bool. All right. Another great memory reduction, city to city, or connected. Connected. I didn't know that you can do something like this. Vector of bool. Now bool of size and looks good though. So all you say is connected. True and true, and then connected AB. Yeah, look at that. So much cleaner. Just this tricky initialization of n of vector and that's it. But basically that's what we did, right? All right, so let's see if it compiles and let's see what are the scores. Could have been, if not, you think, oh, why? I don't understand. Oh, too much of brackets now, right? Because we don't have static cast anymore. Obviously it works. And what's the time and memory? Whoa! Twice less memory and almost 3 times faster. That's why data structures are important. That's why, not just algorithms, but data structures as well. We were almost correct choosing the bool array, 2D array, but you cannot easily initialize it if n is a variable. Right, you also can say constant, but it won't change anything, I would imagine. Will it? I don't think so. Nah. So those are the best scores we could have got today, but we didn't. So it's almost 94 time and 93 memory. So it's 190 what? 6 and no, it's still 187 points. It's not even 100. Anyway, way better. But unfortunately, oh damn, I didn't switch the default scene. So this is the solution we've seen from posted there, right? So we switched from the map of things, we switched just to the vector because we don't care about individual indices, like what edges specifically there, right? All we care is just their number. And we need this connected map to just check if they directly connected to subtract this one thing or not. And the rest is the same. So the algorithm is the same. We nailed the right algorithm immediately. We didn't nail Okay, we almost nailed the way we want to represent if nodes are connected or not, if cities are connected or not. We almost nailed the right data structure. We tried to use 2D array, but we were too lazy to initialize it. And instead of map, it turns because we don't care about individual indexes, so we don't need to have map of integer to the set of indices. All we care is just basically the vector, or it could be 2D array actually, right? It could be 2D array of specific size initialized with zeros, let's say. Let, by the way, check if this will change anything. If we just say int city roads of n initialized at 0, if this change anything, I just wonder. Run the code. Okay. So then we need to say can we just say 0? If no, all right, yeah, whatever. But yeah, so the first data structure was wrong. So that's why we've got too much of memory use, and actually even just the use of maps instead of directly calling specific memory address when you use vector and you refer to index, right? So it's all one axis. Map is technically also all one axis because you have constant transformation using hash, but just switching from map to vector, significant improvements in time, significant reduction in memory. Yeah. But anyway, we solved it. So I guess let's stop here. Instead of fireworks, we saw the better version of the algorithm. And with that, let's end today's stream. So almost 50 minutes. So see you tomorrow, if at all.